Chapter 1, Section 4, solving equations. Now, we had a whole test on solving multiple step equations. We already talked about this once, okay? We're going to add that. I'm going to do another review. That way you can see it again. Okay, the more times you see it, the better, okay? So, I'm going to go through it again. What? You can use whatever you like. You use a highlighter. Okay? Now, solving equations. I need to talk about a few things that are actually known to be obvious, okay, that most students don't see. A lot of times in geometry you use it more than what you actually use it in algebra, okay, when you write proofs, okay. For example, okay, a property that we use a lot of times when we write proofs, the reflexive property, okay. I'm not going to make you write these down. These are in your book. If you want to write them down, you can. You do not have to. I'm just refreshing your memory. These are the rules of equality that we use to solve equations. A equals A. Ta-da! Okay, 6 equals 6. That's called the reflexive property. Okay? Something that you know, I mean, kind of common sense, yeah, well, we as mathematicians put the name the reflexive property on it. Okay? I'm sorry, yes. The symmetric property, okay, says, okay, well, if A equals B, then equals A. Yeah, pretty cool. All right, A equals B, B equals A. It's 6 equals. What was this one called? 6. Then 6 equals 6. Okay, or we can say if A plus 6 equals 6, then 6 plus. Basically, you can switch it around.
That was reflexive.
Well, that one's symmetric. First one's reflexive.
Oh God, telling us all these wrong ones.
Okay. The third one that we talk about is if it's called transitive. Does everyone remember this one? If A equals B and B equals C, then anybody take a guess? A equals C. Well, not A equals A equals C. I tried, but I was off. A equals C. Okay. For example, this is an example I like to give. If 1/2 equals 2/4, and 2/4 equals 6/12, then 1/2 equals 6/12. I'm recording! No! You know where you're going? I'm going this way. Okay? Okay, so we have, first one was reflexive, then we have transitive, or symmetric, then we have transitive. Okay, now, I shut it when I went outside for the fire truck. There it is. And then there's the substitution property. All the substitution property says is this. Okay, if I have A equals B, okay, and I have A plus 6, I can also say B plus 6. It's going to give me the same thing. Okay? Because A is equal to B. I already said A is equal to B, so I can substitute in, okay, a different variable. That works for when you have a solution to an equation, like x equals 4. Because x equals 4, you can take that 4 and plug it in wherever x is. Okay, that's just a substitution property when we're solving equations. That's what property says you can do that. Okay, because that's how we are, us mathematicians. Now, suppose that I have A equals B. Okay? I can, because of the equality property, or of, I think it's called equality property of addition, okay, I can say A plus 3 equals B plus 3. I can add 3 to both sides. Okay? I can also say A minus 6 equals B minus 6. Subtract. Addition, subtraction. What else do you think I could do? Multiplication, division. A times 4 equals B times 4. And last but not least, A divided by 10 equals B divided by 10. Okay, if A equals B, then I can do all of those. Addition, subtraction, one side, you got to do the other. Okay, that's how we solve equations, right? Because of those properties right there. That's the reason we can solve equations. We do things to both sides of the equation in order to eliminate everything except for the variable. So let's do that. Let's do some examples. Suppose I have negative 27 plus 6y equals 3 times y minus 3. Negative 27 plus 6y equals 3 times y minus 3. Now, even in the book, and most of you will probably say, the first step to solving this equation is what?
Parentheses.
Yeah, so we erase the parentheses. How do we do that? Distributive property, okay? Probably 80% of all students would say that. Now, I look at this and I say something completely different, okay? First thing I'm going to do is I'm going to locate the variables, okay? You can make steps for this. I know solving equations, those of you who struggle at solving equations, make these steps. 1, locate the variable. Okay, if you struggle, locate the variable. Well, I have a y on both sides. Step 2, look around the variable. Look at all the numbers surrounding the variable. What is surrounding the variable? Okay? How is it attached to the variable? Okay? In this case, I have this y. This 27 is attached by adding a negative. Okay? This 6 is attached by multiplying. Okay? This 3 is attached by multiplication, and this 3 is attached by subtraction, right? Okay? Now, for me, then I look at, okay, I want to isolate the variables by combining, this is step 3, by combining, combine, and isolate. Well, for me, I say, okay, this is multiplication, right? I don't want to distribute. Okay? I'm going to divide. I'm going to divide both sides by 3, because whatever I do to one side, I can do to the other, okay? You might say, well, why would you do that? Well, here's why. Okay, what's 3 divided by 3? Here. I'm just going to cancel these out, right? I'm left with y minus 3. I just got rid of that 3 without distributing. Okay? Now, on the other side, there is a reason that I divided by 3 instead of distributing that 3 through the parentheses. Is 27 divisible by 3? Yes. Is 6 divisible by 3? Yes. Yes. That is why I divided by 3. Now watch. I want you to remember back to last week when we added fractions. I'll go back up just a minute. Okay? When you add fractions and you have a common denominator already, how do you add fractions? What do? If you're adding a fraction with common denominators? Like for instance, negative 27 over 3 plus 6y over 3. Add across the top. Very good. So technically, this is going to be negative 27 plus 6y all over 3, right? Because that's how you add fractions. You add the numerators together with the same denominator. Well, let me ask you this. If this equals this, doesn't this equal this? Can't I go backwards? If A equals B, doesn't B equal A? Okay? Same thing up here. Okay? I have negative 27 plus 6y over 3, so I can plug in negative 27 over 3 plus 6y over 3. It's the same thing. You might say, well, why do you want to do that? Well, what's negative 27 divided by 3? Negative 9. What's 6 divided by 3? 2y. Now, I'm gone with the parentheses. My 3 is gone. My variables are exposed outside of parentheses. And so I can combine, right? Combine and isolate. So I'm going to subtract y. I'm left with negative 9 plus y equals negative 3. Add 9 to both sides. These are the steps you should have hopefully have learned in Algebra 1. Equals 6.
We find it easier to distribute. Can we just do that?
You can distribute, yes. You can always distribute. However, there are going to be times when you have to do that. That's why I show you so that you know that you can do that. Okay, and how to do it. I always do it that way. I would rather do that than distribute. For me, if both of those are divisible, then I do it that way. I skip this step and just go to this one. All right. Let's do another one. If I have 11 plus 3x minus 7 equals 6x plus 5 minus 3x. Now, I'm locating my variable, step 1. Okay, I have a 3x, and then 6x, and I have a minus 3x. Okay, I can combine like terms on both sides. Okay, I found the variable, but I noticed, look at the numbers attached to the variable. Okay, I can combine like terms. So here I'm going to combine my 11 and minus 7. I get 4. So I have 3x plus 4. See, 11 minus 7 gives me 4, right? And I have 3x still. Or it could be 4 plus 3x, same thing. Because of which property? 4 plus 3x is equal to 3x plus 4? Which property? When they move. 4 plus 3x equals 3x plus 4.
What? Oh,
Remember? No, this is from last section.
what is it?
Yes! The commutative property, remember? Commutative property. I'm always going to go back to those so you guys start remembering those. Okay, commutative property. So I can put it either way. And then I have, combine these terms, 6 minus 3 is 3. So next I'm going to combine and then isolate. So combining my variables, I'm going to subtract 3x from both sides. What happens?
4 equals 5.
4 equals 5. Is that true?
No.
No. So what's the problem here with this equation?
So you put a slash lead.
You put it's not equal, right? So what are the solutions to this equation for x?
No solution.
No solution. Very good. And s. Okay, this is never, ever true. No matter what number you put in there for x, it is never, ever true. Okay? So when I ask you, is the equation sometimes, always, or never true, and you come up with something like a no solution, you're going to say never. Okay? Now, let's do another one.
Wait, we're actually putting that never on there, or what?
If the directions say, which in your homework your directions will say, is the equation sometimes, always, or never true. You have to solve the equation, and depending on what you get, okay, is what answer you put. Suppose I have 6x plus 5 minus 2x equals 4 plus 4x plus 1. Now I'm going to combine my like terms because I locate the variable. I have x's, x, and x. I have lots of x's going on. So first I want to simplify both sides. I'm going to combine my like terms. I have 6x minus 2x is 4x plus 5 equals 4 plus 1 is 5. So I have 4x is 5. Okay, now I'm going to subtract 4x from both sides to combine my variables. 4x minus 4x on both sides cancels out. What am I left with?
5 equals 5.
5 equals 5. True?
Always.
Always true. What is the answer or the solution to this equation? Not always, but it will be always true. But when I ask for the solution to this equation, what will you put? X equals, you're not going to say x equals always. X equals what?
Any.
Any number.
Yeah, any number. How would you put that? So remember? Do you remember this? What does this mean? All real numbers. Remember that? Remember that when we talked about real numbers? Yeah. He said it could equal any number. Well, the way we symbolize that is x can be all real numbers. This is always going to be true. No matter what number you can think of for x, you can pick it in that, remember that big earth of real numbers we have? You can pick any number you want, and it's going to be true for that equation. Okay? That's how you denote that the solution to this equation is all real numbers. Any questions? Okay, that's all I have to say. That's it. Your homework is page 30 in your book, 1 through 32. I see a lot of you have come without a book. So I'm going to
I don't have a book.
lots of pink sheets. I'm going to get you one.